Okay, this is a brief introduction into the energy change that can occur during chemical reactions. So normally we have A and B form C, but we may not always see is that, well, we tend not to see that. There is an energy component that is involved in every single chemical reaction. There's energy that goes into the reaction to start it, which we call the activation energy, but then we also have a total change in energy as a result of the reaction taking place. That total change of energy within the reaction or due to the reaction is called enthalpy, right? And enthalpy, which is the symbol delta H, change in enthalpy, okay? Not the little dot, that's bad. But as it turns out, some reactions are going to cause the outside environment or the surroundings to be cooler or warmer. And it's because energy, in mainly cases heat, is going into the reaction or coming out of the reaction. So one thing that I definitely want to distinguish is heat versus temperature. Okay, temperature. Okay, temperature is a measurement. Okay, it's a measurement. We use a thermometer to measure temperature. Temperature is not heat, and heat is not temperature. Heat is thermal energy. Okay, and that thermal energy tends to transfer from one place to another during chemical reactions. Now, when it comes to a reaction taking place, in any reaction, we have two parts to every reaction. We have the system, and then we have the surroundings. Okay? The system is where the reaction is taking place. This is actually on the molecular level, the reaction taking place. The surroundings is everywhere else in the universe. Okay? So, if I have a chemical reaction taking place, that is the system, everything else is the surroundings. Okay? Well, sometimes if energy ends up needing to go into a system, right? So energy going into the system we'll call endothermic. And by me saying that it's going into the system, we're saying that the system is gaining energy. So when that's the case, endothermic reactions, delta H, meaning the change in energy, is actually greater than 0. Okay? If energy is ever leaving the system, okay, that's what we call exothermic. And if that energy is leaving the system, that means the energy is exiting the system, and we will say that delta H is less than 0. So really, this is a negative delta H, and this is a positive delta H. So the reason why I'm showing you this is because you're going to come across problems where I'm asking for energy change, and the negative and positive, they don't have the numerical weight that you think of in math. Okay? All that sign is telling us is which direction is the energy going. Is the energy going into the system, or is the energy leaving the system? Okay? If the energy is leaving the system, we call it exothermic reaction, and that means delta H is negative. Okay? It has no bearing on how to calculate it. All you have to do is just make sure that you have the proper signage when we do the problems. Okay? Endothermic, same thing. Energy is going into the system, and delta H is positive. And yes, I want you to write the positive down to clearly identify that you were giving me the direction, because that's all those signs are doing. The signs are telling you the direction of the energy. That's all. Okay? Now, so again, we have just a quick sum up, because this is a fairly short video. Right? Here's my system. Right? Within the box, that's where my reaction is taking place. Everywhere else is the surroundings. If heat is going into, because this is heat, right? If heat's going into the system, that means that the change in enthalpy is going to be greater than 0, which means delta H is going to be positive. And if the system is losing energy, that means the system is having energy exit the system. That means delta H is going to be less than 0, which means it's going to be negative. Again, the signage is just referring to direction of the arrow from the system. Has nothing to do with being greater or less than a quantity of 0. As far as does this make things hot or does this make things cold, that can be somewhat deceiving. But in general sense, usually exothermic reactions tend to get warmer. As far as if I'm holding the system, or if I'm holding the vessel that is having an exothermic reaction take place, that that vessel tends to be warm because heat leaves the system and goes to the outside environment, which happens to be my hand. So I start feeling the vessel or the flask be warmer. Likewise, endothermic reactions, they tend to feel cold because the energy is going into the system and it's leaving the surroundings, making my hand feel cold. Okay. Now we're going to have a variety of different examples of endothermic and exothermic reactions and equations, but I just wanted to give you guys a bare bones introduction. So when we start talking about the signage of delta H and potential energy, which we'll talk about in another video, then you can kind of grasp where this energy plays a role in all chemical reactions.